December 1944. The Ardennes Forest, Belgium. Snow fell in thick curtains across the pine trees as German engineering units worked frantically to complete a critical supply bridge over the Salm River, their breath forming clouds in the -15 degrees Celsius air. The bridge represented the lifeline for an entire armored division pushing westward through the frozen landscape, and the soldiers guarding it believed no force on earth could threaten their meticulously constructed crossing point in time to matter. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. What those soldiers could not have known was that their assumptions about who posed a threat and what weapons could destroy their bridge were about to be shattered by a man armed with nothing more than the skills he learned in the logging camps of Oregon. His name was Sergeant James Robert Clayton, 28 years old, born in the timber country outside Portland, to a family that had worked the forests for 3 generations. The Army personnel file listed him as a combat engineer with the 341st Engineer General Service Regiment, one of the few predominantly African-American engineering units serving in the European theater. What the file did not adequately convey was that Clayton had spent 15 years learning the art of precision tree felling, developing an almost supernatural ability to calculate angles, stress points, and the exact sequence of cuts needed to drop a 100-foot Douglas fir within inches of a target zone. His hands bore the calluses of 10,000 axe swings, and his eyes held the steady focus of a man who understood that one miscalculation with a falling tree could kill everyone in a logging camp. Clayton's journey to this frozen Belgian forest had begun in 1942 when he enlisted. His training at Fort Leonard Wood had been largely redundant for someone with his background, and his company commander quickly recognized his exceptional abilities. Now 2 years later, and 4,000 miles from those Oregon forests, Clayton found himself in circumstances his grandfather could never have imagined. The German forces advancing through the Ardennes, in what would later be called the Battle of the Bulge, had achieved complete tactical surprise, punching through American lines with 3 entire armies totaling more than 400,000 men. The offensive had been meticulously planned for months, with German engineering units pre-positioned to construct bridges, clear obstacles and maintain supply routes for the armored spearheads driving toward the Meuse River and ultimately Antwerp. Lieutenant Werner Hoffmann commanded the German engineer platoon responsible for the bridge's construction and defense. 42 years old, a veteran of the campaigns in Poland, France, and the Eastern Front, Hoffmann took professional pride in the structure his men had erected in just 36 hours of continuous work. The bridge spanned 80 meters across the ice-choked river, constructed from massive timber supports sunk deep into the rocky riverbed, with a roadway capable of bearing the heaviest vehicles in the German inventory. Hoffmann had designed the bridge himself, working from principles learned at Technical University before the conflict. Each support beam had been carefully selected from surrounding forest, positioned to distribute load evenly across the structure. The 6 vertical supports each measured 60 centimeters in diameter and extended 4 meters below the waterline. On the morning of December 23rd, Hoffmann stood at the western approach to the bridge, reviewing his defensive positions with his second-in-command, Sergeant Klaus Richter. Their unit had been reinforced with a machine gun section and a squad of infantry, creating a defensive perimeter that extended 300 meters on both sides of the river. Richter, a carpenter from Munich before the conflict, had expressed concern about the exposed timber supports, but Hoffmann had dismissed his worries with the confidence of an engineer who knew his craft. "The Americans are 10 kilometers west," Hoffmann said, his breath frosting in the cold air as he gestured toward the distant tree line. "Their forces are scattered and disorganized. Intelligence reports indicate they have lost contact with their command structure and are retreating in small groups without coordination. By the time they consolidate enough strength to threaten this position, our armored columns will have already passed through and the bridge will have served its purpose." Richter nodded, though his eyes continued to scan the thick forest on both sides of the river. The carpenter's instincts told him that those massive timber supports, while impressively engineered, represented a vulnerability. A skilled woodworker could identify the stress points, could understand how lateral force might affect vertical load-bearing structures. But Hoffman was the officer, the formally trained engineer, and Richter's concerns were merely the worries of a cautious craftsman. "Still, Herr Leutnant," Richter ventured carefully, "those support timbers are vulnerable to directed charges or heavy weapons fire. Perhaps we should consider additional protection, some form of reinforcement around the base of each support." Hoffman shook his head, his expression showing mild irritation at having his design questioned. "Which the Americans do not have in this sector. Intelligence indicates only light infantry elements ahead of us, and they are retreating too quickly to organize any meaningful counterattack. Additional reinforcement would require materials and time we cannot spare. The bridge as designed is more than adequate for the current threat environment. The intelligence was both accurate and fatally incomplete. The American forces in the sector were indeed scattered and retreating, lacking heavy weapons or artillery support that could threaten a defended bridge position. But they were not alone. Mixed among the withdrawing infantry companies were specialist units that had been rushed forward in the initial stages of the German offensive, including elements of the 341st Engineer Regiment, tasked with demolition and obstacle creation to slow the German advance. Sergeant Clayton had been separated from his unit during the chaotic German breakthrough 3 days earlier, when artillery saturated their position. When he regained his bearings, he found himself with 5 other engineers and Lieutenant Michael Peterson, a young infantry officer fresh from Fort Benning, who possessed the humility to recognize expertise when he encountered it. The small group had spent 3 days moving west through the forest, avoiding German patrols. On December 22nd, they received a weak radio transmission. German forces had completed a major bridge over the Salm River. The coordinates placed it approximately 4 kilometers from their position. Lieutenant Peterson had spread a map across a fallen log and studied their position, his young face showing the concentration of someone still learning to read tactical situations. "We're approximately 4 kilometers northeast of that bridge," he said, his finger tracing potential routes through the forested terrain. "If we move through the night, we could reach observation range by dawn tomorrow." "With respect, sir," Corporal Davis had said, his voice carrying the skepticism of a man who had already seen his share of impossible situations. 6 men and an officer can't exactly storm a defended bridge position. Even if we had explosive charges, which we don't, the Germans will have it heavily guarded." "No," Peterson agreed, showing the careful reasoning that marked him as a promising officer despite his inexperience. "But we can observe it and report its location to artillery or air support. If we can get accurate coordinates and bridge specifications back to command, they can organize a proper strike against it." Clayton had been studying the map in silence, his eyes moving between the topographic lines and the blue thread representing the Salm River. His mind was already working through possibilities, seeing patterns that the others missed. "Sir," he said quietly, "may I see those aerial photographs from the briefing packet?" Peterson handed over a folder containing reconnaissance images taken before the German offensive began. The photographs were several weeks old now, showing terrain features that might have changed, but they still provided valuable information about the landscape. Clayton examined them carefully, paying particular attention to the forest composition on both sides of the river. The photographs showed dense stands of pine, spruce, and mixed hardwoods, with several particularly large trees visible even from the air. "What are you thinking, Sergeant?" Peterson asked, noticing the intense focus in Clayton's expression. Clayton's response was measured, his Oregon accent soft but clear, each word chosen with care. "Sir, if that bridge is constructed from timber like most field engineering projects, it depends entirely on vertical support beams sunk into the riverbed. The structural integrity of the entire bridge rests on those supports maintaining their position under vertical load. But vertical supports are vulnerable to horizontal force, lateral stress that they're not designed to resist." The other men looked at him with varying expressions of confusion and interest. Corporal Davis spoke first, his voice showing genuine curiosity. "You're talking about some kind of lateral impact, but we don't have any heavy weapons, and even if we did, trying to hit support beams with rifle fire or grenades would be useless." "Not weapons," Clayton replied, his gaze still fixed on the aerial photographs. "Trees. If that bridge is constructed where I think it is, based on these terrain features, there should be large conifers on both banks within falling distance of the structure. A tree of sufficient size, dropped at the correct angle with adequate momentum, could generate horizontal force measured in tons, more than enough to compromise vertical support beams. There was a moment of silence as the others processed this suggestion. Private Wilson, the youngest member of their group, laughed nervously. "Sergeant, with all due respect, those German soldiers aren't going to just let you walk up with an axe and start chopping at trees near their bridge. And even if they did, how would you know where the tree would fall? I mean, exactly where it would hit." Clayton looked at the young private with patient seriousness. "Private, I've been dropping trees since I was 13 years old in the Oregon forests with my father and grandfather. I've dropped over 3,000 trees in 15 years, and I can tell you exactly where each one fell, because precision is how you stay alive in timber country. The principles are physics and geometry. Calculate the lean, height, center of mass, identify the target zone, then make cuts in a specific sequence. The undercut determines direction, the back cut triggers the fall, the hinge wood controls final motion. Done correctly, I can drop a 100-foot tree within a 1-meter circle." Sergeant Foster, who had been listening carefully, asked the critical question. "But you'd need to work close to the bridge, right? Within what, maybe 100 meters? And you'd be making noise cutting wood. The Germans would hear you." "They would if I worked during the day," Clayton agreed, "but timber work doesn't require light if you know what you're doing. I've worked night shifts in the Oregon forests during winter when we had deadlines to meet. You can't see as well, but you can feel the tree, understand its balance, know when your cuts are reaching the right depth. And the noise can be masked by other sounds, wind, river flow, even by creating a diversion elsewhere." Lieutenant Peterson evaluated the proposal. "Sergeant Clayton, you're proposing that we infiltrate the German perimeter, identify a suitable tree, prepare it for felling at night, and trigger its fall to strike the bridge supports." "Yes, sir." "And you believe this is feasible?" Clayton met his eyes directly. "Sir, I can't promise complete bridge collapse. That depends on variables I won't know until I see the structure. But I can promise that if I identify the right tree and make proper cuts, it will fall exactly where I calculate. And a tree of sufficient size falling with full gravitational force will damage or destroy whatever it hits." Over the next hour, as the group moved cautiously through the forest toward the German position, Clayton outlined his plan in more detail. The concept was simultaneously brilliant and audacious. Identify the largest tree within falling distance of the bridge's main supports, prepare it with carefully calculated cuts during darkness, and then trigger the final fall at a moment when German attention was focused elsewhere. The technical challenge was immense. Clayton would need to work in near total darkness, maintain absolute silence, and achieve precision that would be difficult even in ideal conditions. "The hardest part," Clayton explained as they moved through the snow, "isn't making the tree fall. Gravity does that once you've removed enough wood. The challenge is controlling exactly where it falls. A tree 80 to 90 feet tall carries enormous momentum. If the angle is off by even 3 or 4 degrees, it'll miss entirely or hit wrong." Corporal Davis asked, "And if something goes wrong?" Clayton's response was honest. "Then we've lost surprise and need to escape quickly. But in 15 years, I've never had a tree fall more than 2 meters from where I calculated. Not once." They reached observation range of the bridge 2 hours before dawn on December 24th. From a position 300 meters northeast of the structure, concealed in a thick stand of evergreens, they could see the German defensive positions, the regular patrols, and the constant flow of vehicles across the bridge. Even in the pre-dawn darkness, the bridge was an impressive sight, a substantial structure that spoke to the skill of whoever had designed it. Clayton spent the remaining darkness hours surveying the forest on the western bank, looking for the perfect candidate tree. He needed something large enough to generate sufficient impact force, positioned at the correct angle to fall toward the bridge, and structurally sound enough to maintain its integrity during the fall. A rotten or damaged tree might break apart mid-fall, dissipating the force that Clayton was counting on. He found it just as the first grey light touched the eastern sky. A Norway spruce standing approximately 90 feet tall, positioned 120 meters from the bridge at an angle that would, if calculations proved correct, allow it to fall directly onto the 2 central support beams. The tree was magnificent, a healthy specimen that had probably been growing in this forest for 7 or 8 decades. Its trunk was straight and true, with no visible damage or rot, and the branch distribution indicated that its center of mass was properly positioned for the fall Clayton envisioned. "That's the one," he whispered to Lieutenant Peterson, pointing out the massive conifer with a gesture that was almost reverent. For a man who had spent his life working with trees, there was something sobering about selecting such a fine specimen for destruction. Peterson studied the tree through binoculars, then looked back at Clayton with concern evident on his young face. "Sergeant, that tree is well within the German defensive perimeter. I can see patrol routes that pass within 20 meters of its base. There's no way to approach it without being seen during daylight hours." "Not during daylight," Clayton agreed, his mind already working through the approach route, the timing, the sequence of actions required. "But tonight, if we can create enough distraction elsewhere, I can make the primary cuts. Once the tree is properly prepared, the final trigger cut can be made quickly. Less than a minute if the setup is correct." The plan they developed over the next several hours was risky to the point of recklessness, but given their limited options and the strategic importance of the bridge, Peterson approved it, with the caveat that they would abort if the risk became too great. They would wait for full darkness on Christmas Eve, then create a diversionary probe on the eastern side of the bridge, using small arms fire and movement to simulate a small patrol making contact. While German attention focused on that threat, Clayton would approach the spruce tree from the north using the terrain and darkness as cover and begin his work. That day, December 24th, passed with agonizing slowness. The American soldiers remained hidden in the frozen forest, watching German vehicle traffic cross the bridge in steady streams. Tanks, half-tracks, supply trucks, and infantry carriers all heading west toward the front lines, where American forces struggled to contain the massive offensive. Each vehicle that crossed represented supplies and reinforcements that would make the battle harder for Allied forces, that would cost American lives in the days and weeks ahead. Clayton used the daylight hours to observe every detail of the bridge structure he could see from their position. He noted the spacing between support beams, estimated their diameter based on comparison with known reference points, studied how the horizontal bracing connected the vertical elements. He watched how the bridge responded to vehicle weight, looking for any flex or movement that might indicate structural weaknesses. By the time darkness fell, he had created a mental model of the bridge that was nearly as detailed as Hoffman's engineering drawings. The other men took turns on watch, ensuring that German patrols didn't stumble across their position. They were all experienced enough to maintain noise discipline, to move carefully when changing positions, to avoid creating any telltale signs that might alert nearby enemy forces. Lieutenant Peterson organized their withdrawal route, identifying multiple paths back to American lines in case their primary route was compromised. As darkness fell, the temperature dropped to -18 degrees Celsius. Clayton prepared his tools with the methodical care of a craftsman who understands that his life depends on his equipment. 2 hand axes, carefully sharpened until their edges could shave hair. A 2-man crosscut, saw that would be operated by him alone, its teeth set to cut frozen wood efficiently. A small folding shovel to clear snow from the work area and expose the tree's base. He wore dark clothing stripped from a German casualty they had found in the forest, hoping the silhouette would buy him a few extra seconds if spotted. At 2200 hours, with snow falling heavily enough to muffle sound and reduce visibility, the diversionary team, Lieutenant Peterson, Corporal Davis, and Private Wilson, moved into position on the eastern bank. They carried their M1 rifles and a limited supply of ammunition, enough to create the impression of a small patrol making contact with German positions, but not enough for sustained combat. The plan called for them to fire deliberately high, creating noise and muzzle flash without actually trying to hit German soldiers. The goal was to draw attention, not to provoke a major engagement. At 22:15, Peterson opened fire, the sharp crack of his M1 rifle shattering the winter silence. Davis and Wilson joined in immediately, their weapons creating a staccato rhythm that echoed across the frozen landscape. The German defenders reacted exactly as anticipated, with machine guns opening up toward the muzzle flashes and infantry moving to reinforce the eastern perimeter. Voices called out in German. Officers shouting orders, the organized chaos of a well-trained unit responding to contact. Clayton moved during this chaos, covering the 300 meters to the spruce tree in a low run that used every shadow and depression in the terrain. His path took him through a small ravine across a frozen stream and finally up a slight rise to where the massive conifer stood. He reached the base of the tree undetected, dropping to his knees beside the trunk and immediately beginning his assessment. His hands, even through heavy gloves, could read the tree's characteristics with the sensitivity of a master craftsman. The slight lean to the southwest, perhaps 3 degrees from vertical, that was good. It would help the fall in the direction he wanted. The distribution of branches indicating where the center of mass would be during the fall, slightly forward and left, which he would need to account for in his cuts. The way the trunk swelled at the base indicating the root structure below, solid and well established, which meant the tree would resist falling until the cuts were nearly complete. The diversionary fire continued for another 3 minutes, then ceased as planned. Clayton remained absolutely motionless beside the tree, listening as German voices called out in the darkness as the defensive positions gradually settled back to normal alertness. He waited a full 20 minutes before beginning his work, using the time to finalize his mental calculations and to allow his eyes to fully adjust to the darkness. The primary cut, called an undercut or notch in logging terminology, would determine the direction of fall. This was the most critical element of the entire operation. If the undercut was positioned incorrectly or cut at the wrong angle, the tree might fall in an uncontrolled direction, regardless of what Clayton did with the back cut. He positioned himself on the southwest side of the trunk, facing toward the bridge, and began cutting with one of his axes. Each stroke was carefully controlled, the blade biting into the frozen wood with soft thuds that were masked by the wind moving through the pine branches overhead. The sound was no louder than a woodpecker, and in the darkness and snow it would be virtually impossible to locate, even if someone heard it. Clayton worked in a rhythm developed over 15 years, the axe becoming an extension of his arms, each cut placed with absolute precision to create the wedge shape that would guide the tree's fall. The undercut needed to penetrate approximately 1/3 of the tree's diameter, angled downward at 45 degrees, to create a notch that would open as the tree fell. This notch would face the direction Clayton wanted the tree to fall, directly toward the bridge's central supports. In daylight conditions with proper tools and no threat of detection, creating this undercut would have taken Clayton perhaps 20 minutes. In darkness, in freezing temperatures, with the constant threat of German patrols, it took him nearly 2 hours. His hands ached from the cold and the impact vibrations transmitted through the axe handle with each stroke. Sweat froze on his forehead despite the temperature. His back cramped from maintaining the awkward cutting position, half kneeling beside the massive trunk. But the cut progressed exactly as planned, the notch deepening with each careful stroke, the angle remaining true to his initial calculations. At 01:30 hours, the undercut was complete. Clayton paused to rest and to listen for any indication that German forces were aware of his presence. The night remained quiet except for the wind and the distant sound of vehicles crossing the bridge. He moved to the opposite side of the tree and began the back cut, the horizontal cut that would sever the remaining wood and allow the tree to fall. This cut required even more precision than the undercut. It needed to be perfectly horizontal, positioned slightly higher than the point of the undercut, and stopped before it met the notch to leave a small hinge of wood that would control the fall direction during the final moments. The hinge was critical. Too thin and it would break prematurely, allowing the tree to fall uncontrolled. Too thick, and it might prevent the fall entirely or redirect it in an unintended direction. He used the cross-cut saw for the back cut, working alone with the long blade in a steady rhythm that kept the kerf, the channel being cut, straight and true. Operating a 2-man crosscut saw alone was exhausting work, requiring Clayton to use his entire body to drive the blade through the frozen wood. But it was quieter than an axe and created a cleaner, more controlled cut. The saw's teeth bit through the frozen spruce with a soft rasping sound that blended with the wind and the natural creaks and groans of the forest. Clayton's world narrowed to the immediate task. Maintain the angle. The saw had to stay perfectly horizontal, or the back cut would be compromised. Keep the pressure even. Too much force and the saw would bind in the kerf. Too little and it would skip across the wood without cutting effectively. Feel the resistance change as the blade moved through different wood densities. The sapwood cut differently than heartwood, and Clayton needed to know exactly how deep the cut had penetrated. At 0300 hours, with the back cut nearly complete, Clayton heard voices approaching. German patrol, 2 soldiers walking the perimeter and talking casually about Christmas at home. One was telling a story about his children, about how his daughter had asked in her last letter whether he would be home for the holiday. The other soldier laughed and said something about believing in miracles. Clayton froze with the saw blade still in the cut, his body pressed against the far side of the trunk where the shadows were deepest. His heart hammered in his chest, but his breathing remained controlled, silent. The soldiers passed within 20 meters of his position, their conversation drifting through the darkness, completely unaware of the American engineer and his partially severed tree. Clayton could smell their cigarette smoke, could hear the crunch of their boots in the frozen snow. When the patrol had moved on, their voices fading into the distance, Clayton waited another 10 minutes before resuming his work. His hands were shaking slightly from the adrenaline and the cold, and he took several deep breaths to steady himself before picking up the saw again. The back cut was nearly complete. He estimated another 20 minutes of work would bring it to the correct depth. At 0345 hours, Clayton made the final stroke with the saw and carefully withdrew the blade from the kerf. The back cut was complete, penetrating to within approximately 10 centimeters of the undercut on the opposite side. Those 10 centimeters of wood, the hinge, represented the only thing now holding the massive spruce tree upright. The tree was in a state of delicate balance, like a door standing slightly ajar. A strong wind could potentially trigger the fall, but under current conditions, it would hold until deliberately pushed or pulled in the correct direction. Clayton marked the tree with a small strip of white cloth tied at shoulder height on the side, facing away from the bridge. This would allow him to identify the tree quickly when he returned to trigger the fall. He then withdrew from the German perimeter as carefully as he had entered, moving in a wide arc that kept him in the deepest shadows, pausing frequently to listen for patrols or any indication of alarm. He rejoined Lieutenant Peterson and the others at their observation post just as the first grey light of Christmas morning touched the eastern horizon. His clothes were soaked with sweat despite the freezing temperature, and his hands were bleeding slightly where the wooden handles had worn through his gloves during the hours of work. "It's ready," Clayton reported quietly, accepting a canteen of water from Corporal Davis and drinking deeply. "The tree will fall with approximately 15 to 20 meters of lateral push applied at the marked point. Given the current lean and the hinge position, it should impact the bridge's 2 central supports about 3 meters above the waterline. The impact angle will be roughly 45 degrees from horizontal." "Should?" Peterson asked, his young face showing the concern of an officer about to commit his men to a dangerous course of action based on a plan he didn't fully understand. Clayton met his eyes steadily, and when he spoke, his voice carried absolute conviction. "Sir, I've dropped over 3,000 trees in my career. I know how timber falls. I know how to read a tree's lean and balance. I know how to calculate the impact point based on height and angle. This tree will hit where I calculated it to hit, plus or minus half a meter. That's not a guess or a hope. That's professional expertise based on 15 years of doing this exact work." They spent Christmas Day observing the bridge and planning the final phase of their operation. The German defenders appeared relaxed, celebrating the holiday with reduced patrols and what sounded like singing from their positions. Someone had apparently organized a small celebration, and the Americans could smell cooking food on the wind. Vehicle traffic across the bridge continued, but at a reduced rate, suggesting that even in the midst of a major offensive, German forces were acknowledging the significance of the day. Lieutenant Hoffman made several inspection tours of the bridge, his professional satisfaction evident even from a distance. He walked the length of the structure, examining joints and connections, occasionally stopping to speak with Sergeant Richter or one of the other engineers. To Hoffman, the bridge represented the successful application of his training and expertise. It was solid, functional, and beautiful, in the way that well-engineered structures can be beautiful. He had no way of knowing that his creation was already doomed. that 120 meters away stood a tree prepared with such precision that its fall would undo in 30 seconds what had taken 36 hours to build. What Hoffman and his men did not know, what they could not have known, was that their bridge was already doomed. The massive spruce tree standing innocuously in the forest had been transformed into a precisely calibrated weapon, waiting only for its final trigger. Every calculation had been made, every cut placed exactly where it needed to be. The tree stood like a loaded gun, and Clayton held the trigger. The plan for triggering the fall required careful timing and coordination. Clayton would need to approach the tree one final time, but now he needed to apply lateral force to push it past its balance point. The method for applying this force came from standard logging practice, a rope tied high on the trunk and pulled from a position of relative safety. But getting the rope in place required another nighttime approach, another 2 hours of moving through German-controlled territory while trying to remain undetected. On the night of December 25th, Clayton made his second journey to the spruce tree. This time, he carried a coil of rope and a small grappling hook fashioned from tent stakes and wire. The German positions were quiet, the soldiers likely exhausted from their holiday celebrations. Clayton reached the tree without incident, threw his grappling hook to catch a sturdy branch at 20 feet, and climbed rapidly using the rope. At the white cloth marker, approximately 15 feet above ground level, he tied off the rope with a timber hitch, a knot specifically designed to grip wood under tension. He created a simple mechanical advantage system using the rope, routing it through a fork in the branches and back down to ground level. This arrangement would allow him to apply pulling force from a safe distance while multiplying the effect through the leverage of the higher attachment point. He was descending about 10 feet from the ground when a German voice called out in the darkness, "Halt! Identify yourself!" Clayton froze on the rope, hanging against the trunk, as a German soldier approached with a flashlight. The soldier was young, perhaps 19, and appeared to be responding to movement he had glimpsed rather than having a clear target. His flashlight beam swept the area around the tree base, passing within a meter of Clayton's position, but failing to angle upward far enough to illuminate him hanging on the rope. "Probably just an animal," the soldier muttered to himself, and Clayton heard him speaking into a radio in German. "Western perimeter, grid 7-4. Thought I saw movement near the large spruce, but it's negative. Probably a deer or something. Returning to patrol route." The soldier lingered for what felt like an eternity, but was probably no more than a minute, his flashlight continuing to probe the darkness around the tree. Clayton hung motionless on the rope, barely breathing, his muscles screaming from the strain of holding his position. Finally, the soldier moved on, his footsteps crunching in the snow as he continued his patrol. Clayton remained motionless for a full 10 minutes after the soldier disappeared, listening for any indication that the alarm had been raised or that additional soldiers were approaching. When he was satisfied that the danger had passed, he completed his descent and carefully arranged the free end of the rope so it extended away from the tree in the direction opposite from where he wanted it to fall. This would allow him to pull from a relatively safe position while directing maximum force toward triggering the fall. He marked the rope's position with small stones, arranged in a pattern he would be able to find by feel in darkness, then withdrew once again from the German perimeter. By 0400 hours he was back at the observation post, cold and exhausted, but satisfied that everything was in place. December 26th dawned clear and cold, the sky a brilliant blue that seemed almost obscene given the violence and death that surrounded them. German activity around the bridge increased significantly as a column of heavy vehicles prepared to cross. Intelligence had clearly reached them about American counterattacks developing to the west, and reinforcements were being rushed forward to support the German spearheads that had penetrated deepest into Allied lines. Lieutenant Hoffman personally supervised the morning traffic, ensuring proper spacing between vehicles to avoid overloading the bridge structure. He watched with satisfaction as tank after tank crossed his creation without incident, the roadway holding firm under loads that would have collapsed a lesser bridge. He had done good work here, Hoffman thought. When this offensive was over, when Germany had achieved victory in the West, this bridge would stand as a testament to German engineering excellence. At 0915 hours, A particularly heavy tank, one of the massive King Tiger vehicles that represented the pinnacle of German armored development, began crossing from the east. The vehicle weighed approximately 70 tons, close to the maximum load Hoffmann had designed the bridge to support. He watched carefully as it moved across, noting with professional pride that the structure showed no dangerous flex or stress indicators. At 0930 hours, with the King Tiger halfway across the bridge and 3 more heavy vehicles queued behind it, Lieutenant Peterson made his decision. Sergeant Clayton, prepare to trigger the fall. We'll open fire on the eastern positions exactly 3 minutes after your tree starts moving, to cover your withdrawal and keep German attention divided. Clayton nodded and moved to where they had concealed the rope under brush and snow. The other soldiers took firing positions, their weapons aimed at the German defensive line. The massive spruce tree stood silent and apparently harmless in the winter sunshine, its prepared cuts invisible from any distance. Soon, very soon, it would deliver a lesson in physics and precision that the German engineers would never forget. "Sir," Clayton said quietly to Peterson, "once this tree falls, those German soldiers are going to realize immediately that someone deliberately sabotaged it. They'll search this entire area with everything they have. We need to be gone before they can organize their response." "I know," Peterson replied, his young face showing the gravity of their situation. "Which is why we're going to be 5 kilometers west before they even start looking. Everyone clear on the withdrawal route? We move fast, we move quiet, and we don't stop until we've put serious distance between us and this position." The men confirmed their understanding with quiet affirmations and nods. They had been through enough combat to know that the minutes following the tree fall would be the most dangerous of the entire operation. German forces would be angry, confused, and looking for someone to blame. The Americans needed to be gone before that search began in earnest. Clayton gripped the rope, feeling the tension in it even before he began pulling. The rope stretched slightly under his initial pressure, the knots holding firm. He braced his feet against a solid tree trunk and began to pull with steady, increasing force. The rope stretched and creaked as tension built, transmitting that tension through the branches to the prepared trunk of the spruce tree. For a long moment, nothing happened. The massive tree stood exactly as it had for perhaps 80 years, rooted in the Belgian soil, reaching toward the winter sky. The hinge wood was holding, resisting the force being applied, fighting against the pull of gravity and human strength. Then, with a crack that sounded like rifle fire echoing across the valley, the hinge wood began to tear. The massive tree leaned, slowly at first, its movement barely perceptible. But physics and gravity and Clayton's 15 years of expertise had all combined to create an inevitable result. The lean increased, accelerating as the tree's center of mass moved past its balance point. The hinge wood, that critical 10-centimeter strip that Clayton had left to control the fall direction, tore progressively from the back toward the front, guiding the tree exactly as he had calculated it would. Clayton released the rope and dropped flat as the spruce began its fall, the sound building from a creak to a groan to a roar as 90 feet of timber and branches accelerated toward the earth under gravitational force. The tree fell directly toward the bridge, its trajectory as true as if it had been aimed by precision instruments. The massive trunk remained intact during the fall, all of Clayton's calculations about the tree's structural integrity proving correct. German soldiers around the bridge looked up at the sound, their faces showing confusion that transformed to horror as they realized what was happening. Some began to run, though there was nowhere to go that would save them. Others simply stood frozen, watching the impossible scene unfold before them. Hoffmann saw it too, his engineering expertise allowing him to calculate the impact point in the second before it occurred, to understand with terrible clarity that his bridge was about to be destroyed by a method he had never even considered. The spruce struck the bridge's 2 central support beams with the force of a meteor. The impact occurred almost exactly where Clayton had calculated it would, 3 meters above the waterline, at an angle of approximately 43 degrees from horizontal. The sound echoed across the valley, a tremendous crash of shattering wood and stressed timber that could be heard for kilometers. Birds erupted from trees throughout the forest, their alarmed calls adding to the chaos. The support beams, despite their 60-centimeter diameter, and their foundations, sunk 4 meters into the rocky riverbed, simply could not withstand the horizontal force generated by a 90-foot tree traveling at terminal velocity. The impact energy was measured in tons, delivered in a fraction of a second to structural elements designed only to resist vertical loads. Both beams snapped at the waterline, the failures occurring almost simultaneously, with sharp reports like cannon fire. The break propagated upward through the structure, as the weight above suddenly had no support, each joint and connection failing in a cascading collapse that took less than 5 seconds from initial impact to final destruction. The roadway section supported by those beams dropped into the river, taking with it a half-track vehicle that had been in mid-crossing. The vehicle tilted sideways as the roadway fell away beneath it, its occupants visible for a brief moment before it struck the water and disappeared beneath the surface. The King Tiger tank, still on the eastern approach, had stopped automatically when its driver saw the tree falling, and that stop saved the crew's lives. Another 3 meters forward, and the massive tank would have followed the half-track into the frigid water. The entire bridge structure twisted and sagged as the loss of the central supports redistributed loads onto the remaining beams. These beams, now carrying weights they were never designed to bear, began to fail in sequence. First, the support immediately west of the broken beams snapped at its foundation connection, the stress too great for the joint to withstand. Then the eastern support adjacent to the gap gave way. Its foundation literally pulled from the riverbed by the horizontal forces generated by the collapsing roadway. Within 30 seconds of the initial impact, the entire western span of the bridge had collapsed into the Salm River, leaving only the eastern approach still standing, a truncated reminder of what had been an impressive engineering achievement. The destruction was total and catastrophic. Hoffman's masterpiece of field engineering had been reduced to twisted wreckage in less than a minute of real time. Debris floated in the river, carried downstream by the current. The roadway that had supported 70-ton tanks now lay in pieces at the river bottom. The support beams that Hoffman had so carefully positioned and founded were now broken stumps or floating logs. Hoffman stood at the eastern approach, his face pale with shock, staring at the impossible scene before him. Around him, his soldiers were emerging from their defensive positions, equally stunned, trying to process what they had just witnessed. Some were pointing at the fallen tree, at the obvious cuts in its trunk that were now visible to anyone who looked. Others were staring at the wreckage in the river, perhaps thinking about the men who had been in that half-track when it fell. "Mein Gott," Sergeant Richter breathed beside Hoffman, his carpenter's eye immediately recognizing the professional quality of the cuts in the spruce trunk. "What happened? How did that tree fall exactly onto the bridge supports?" Hoffman's eyes moved from the wreckage to the fallen spruce tree, studying the exposed cuts with an engineer's precision. Even in his shock, his training allowed him to recognize what he was seeing. The undercut was textbook perfect, a clean 45-degree notch that had determined the fall direction with absolute precision. The back cut was equally professional, perfectly horizontal, stopped at exactly the right depth to leave a hinge of appropriate thickness. These were not random cuts or lucky damage. This was expert work. "Someone dropped that tree deliberately," Hoffman said slowly, his voice carrying a mixture of professional recognition and profound disbelief. "Someone who knew exactly where and how to cut it for maximum effect. This wasn't luck or accident. This was precision forestry applied as a weapon." The German soldiers around the bridge began to react, moving from shock to anger to action. Officers shouted orders, organizing search parties to comb the surrounding forest for whoever had sabotaged the tree. Machine gun teams took up firing positions covering all approaches. Infantry squads formed into search lines, preparing to sweep through the woods in coordinated patterns. But the American team was already gone, moving rapidly west through the forest while German attention focused on their ruined crossing point. Clayton led the withdrawal, using his knowledge of terrain and his timber worker's instinct for finding paths through dense forest. They moved fast, but carefully, knowing that speed meant nothing if they left a trail obvious enough for German troops to follow. They traveled for 6 hours before stopping to rest, putting nearly 10 kilometers between themselves and the bridge site. The group paused in a small clearing, each man dropping to the ground with the exhausted relief of soldiers who have survived a dangerous operation. Peterson looked at Clayton with something approaching awe as he pulled out his map to verify their position. "Sergeant," Peterson said, "I have seen artillery destroy bridges. I've seen aerial bombardment reduce them to splinters. I've read reports of demolition teams using hundreds of pounds of explosives to collapse major structures. But I have never seen, and never imagined I would see, anything quite like what you just accomplished with hand tools and knowledge." Clayton was cleaning his axes with snow, his movements automatic and practiced, the ritual of a craftsman caring for his tools. "Just timber work, sir. Same principles whether you're clearing a logging road in Oregon or taking down a bridge in Belgium. The physics doesn't care about the application. A tree falls the way it's cut to fall every single time." "Those German soldiers," Corporal Davis said, accepting a canteen from Private Wilson and drinking deeply. "They never even considered that someone could destroy their bridge with nothing but axes and saws. They were focused on explosive charges, heavy weapons, aerial attack. They had guards and patrols and defensive positions all oriented toward conventional threats." "That's the thing about assumptions," Clayton replied quietly, his Oregon accent soft but clear in the winter air. "They make you blind to threats that don't fit your expectations. Those German engineers built a good bridge, solid design, proper construction, adequate foundations. But they designed it to resist vertical loads and conventional attacks. They never imagined someone would use a tree as a horizontal impact weapon." Private Carter, who had been silent for most of the operation, spoke up. "Sergeant, how did you learn to do that? I mean, not just cutting trees, but seeing the possibility, understanding that a bridge could be destroyed that way." Clayton paused in his cleaning, considering the question. "When you work timber for long enough, you start to see the world differently. You stop seeing trees as just plants and start seeing them as mechanical systems, levers, weights, forces in balance. 100-foot Douglas fir weighing maybe 8 tons, standing 90 feet tall, represents enormous potential energy. Drop it from that height, and you're releasing energy equivalent to multiple artillery shells, but directed precisely where you choose rather than scattered in a blast pattern." He resumed cleaning his axes, his voice taking on the reflective tone of someone explaining expertise they've lived with so long, it's become instinct. "My grandfather used to say that timber work teaches you to think in 3 dimensions and 4 forces: gravity, tension, compression, and shear. Every tree is a structure under stress, and if you understand how to manipulate those stresses, you can make the tree do exactly what you want. Taking down a bridge is just applying those same principles to a different structure." The impact of the bridge destruction extended far beyond the immediate tactical situation. The German column that had been preparing to cross was delayed for nearly 18 hours while engineering units constructed a replacement span using materials and labor that were desperately needed elsewhere. That delay, combined with similar disruptions at other crossing points throughout the Ardennes offensive, contributed to the eventual failure of German forces to reach their strategic objectives. The Battle of the Bulge would continue for weeks, but the momentum that might have been maintained through rapid movement and efficient logistics was fatally disrupted. Lieutenant Hoffman submitted a detailed after-action report describing the bridge destruction, documenting every aspect of what had occurred with the precision of a trained engineer. His analysis of the tree cuts was technically exact, noting the expertise required to achieve such results and the sophistication of the plan that had been executed against his position. The demolition was accomplished through the controlled felling of a mature Norway spruce approximately 27 meters in height, Hoffman wrote in his report. The tree was prepared through a series of precise cuts that demonstrate expert-level forestry knowledge. The individual responsible calculated the fall trajectory with remarkable accuracy, achieving an impact point within half a meter of what would be required for maximum structural damage. The horizontal force generated by the falling tree exceeded the design parameters of our vertical support beams by an estimated factor of 5, resulting in catastrophic failure of the bridge structure. He continued in a separate section of his report. It is almost impossible to defend against an attack that uses natural terrain features as weapons. We were prepared for conventional demolitions, for artillery bombardment, for aerial attack. We were not prepared for someone who could transform the forest itself into an offensive tool. This represents a significant gap in our defensive planning that should be addressed in future operations. German intelligence officers who read Hoffman's report struggled to explain how an American soldier with logging skills had penetrated the defensive perimeter, prepared a tree for demolition, and escaped undetected. Some suggested it must have been a team of sappers with special training. Others theorized about new American demolition techniques using natural materials. None of them could quite accept that a single man with axes and saws could have accomplished what heavy weapons and explosives had failed to achieve at other bridge sites. The report eventually made its way to higher command levels, where it was filed with other after-action documents from the failed Ardennes offensive. In the chaos of Germany's final months, as Allied forces pushed eastward from all directions, the lesson of the Somme River Bridge was largely forgotten by German forces. But American military intelligence found the report after the conflict ended, and it became part of a larger study on unconventional warfare techniques and the military applications of civilian expertise. Years after the conflict ended, Hoffman and Clayton would meet by chance at an international timber industry conference in Munich. Both men had returned to civilian life, Hoffman as a structural engineer working on reconstruction projects throughout Germany, Clayton as a logging operations supervisor for a major timber company that had operations in both the United States and Europe. Their initial conversation was awkward, two former enemies finding themselves at the same professional gathering, uncertain how to navigate the social complexities of their shared history. Their second meeting was less awkward. They found themselves at the same technical presentation on bridge construction techniques and afterward shared a table in the conference dining hall. The conversation began with professional topics, new developments in structural engineering, advances in timber harvesting technology, the challenges of post-conflict reconstruction. But eventually, inevitably, they began discussing the bridge over the Somme River. "I read your report," Clayton said during that conversation, his voice carrying both respect and a hint of amusement. "The one about the bridge destruction. Your technical analysis was exactly correct in every detail. I was impressed by how accurately you reconstructed what I had done just from examining the cuts afterward." Hoffman smiled slightly, a gesture that softened his normally serious expression. "I confess, when I saw those cuts in daylight after the initial shock had worn off, I found myself admiring the craftsmanship even as I cursed the result. To make such precise calculations in darkness, in enemy territory, under constant threat of detection, it was remarkable work by any professional standard." They discussed the technical aspects of the bridge destruction for hours, two professionals sharing insights across what had once been an unbridgeable divide of war and ideology. Hoffman wanted to know exactly how Clayton had calculated the fall angle in complete darkness, how he had ensured the cuts were placed at exactly the right depth, how he had maintained precision under such difficult conditions. Clayton wanted to know how Hoffman had achieved such impressive load distribution in the original bridge design, what materials and construction techniques he had used, how he had managed to complete such a complex structure in just 36 hours. At one point, Hoffman asked the question that had troubled him for years. "Did you know with certainty that those support beams would fail completely? Or was there some element of uncertainty in your calculations?" Clayton considered the question carefully before responding, his engineer's mind appreciating the precision of what was being asked. "In logging, we have a saying, a tree will always fall where physics demands it fall. If your cuts are correct and you account for all the variables, lean, center of mass, wind conditions, structural integrity, the result is inevitable. But there's always some uncertainty. Wood has grain variations you can't see from the outside, hidden rot or damage, stress fractures that only reveal themselves when the tree starts to move. I believed the impact would be sufficient to compromise those supports based on the force calculations, but I couldn't be certain until it actually happened." "And if it had failed?" Hoffman pressed, his engineering mind wanting to understand the contingency planning. "If the tree had fallen, but the bridge remained standing?" Clayton's response was matter-of-fact. "Then I would have needed a different plan, and we would have needed to escape the area very quickly before your forces organized a comprehensive search. But the tree fell where I calculated it would fall, sir. Everything else, the bridge destruction, the collapse of the supports, the catastrophic failure of the structure, all of that followed inevitably from that single fact. The story of the bridge destruction gradually became something of a legend within the Army Corps of Engineers and among combat engineers more broadly. Clayton's service file was eventually declassified decades after the conflict, revealing that he had received a Bronze Star for his actions during the Battle of the Bulge. The citation was deliberately vague, using carefully neutral language that obscured the specific details of what he had accomplished. For meritorious achievement in connection with military operations against an enemy of the United States. But among combat engineers who knew the full story, Clayton's accomplishment was recognized for what it truly was, a masterful demonstration that expertise and knowledge could be as effective as conventional weapons, that the ability to see solutions others missed was often more valuable than overwhelming firepower. His action had delayed German forces, disrupted their logistics, and contributed in a small but meaningful way to the eventual Allied victory in the Ardennes. The 341st Engineer General Service Regiment continued serving throughout the European campaign, building bridges to replace those destroyed by conflict, clearing roads of obstacles and mines, supporting combat operations with the infrastructure that modern warfare demands. The regiment's African-American soldiers faced discrimination and prejudice, even as they risked their lives in service of their country, enduring insults and exclusion from opportunities available to their white counterparts. Yet they persisted, demonstrating competence and courage that would eventually contribute to significant changes in American military policy. The performance of African-American units during the conflict, including the combat engineers who served with distinction throughout Europe, provided evidence that racial segregation in the military was not only morally wrong, but operationally inefficient. This evidence would contribute to President Truman's decision to desegregate the armed forces in 1948, marking a significant step toward broader civil rights reforms in American society. Clayton himself remained in the Army until 1947, serving in Germany during the initial occupation period and contributing to Reconstruction efforts. He then returned to Oregon and the timber industry he knew so well, taking a position with a major logging company where his expertise and reputation ensured rapid advancement. By 1955, he was supervising operations across multiple logging camps, training the next generation of timber workers in the precision and care that had defined his own career. He rarely spoke about the bridge destruction, deflecting questions with modest explanations that minimized his role. When younger loggers heard the story and asked him about it, Clayton would typically respond with something like, "Just applied what I learned from my grandfather about how trees fall. The circumstances were different from what I was used to, but the physics was the same." This modesty was entirely characteristic. Clayton had never been one for self-promotion or dramatic gestures. He was a craftsman who had applied his skills to an unusual problem and achieved exactly the result he had calculated. The Norway spruce that destroyed the bridge had been approximately 83 years old when it fell, its growth rings later counted by German engineers who salvaged timber from the wreckage for use in the replacement bridge. The tree had sprouted from a seed sometime around 1861, had grown through decades of European history, had stood silent witness to the transformation of the continent from agricultural society to industrial power. It had weathered storms that destroyed lesser trees, had survived winters more severe than that December cold snap, had endured all the changes and upheavals of the late 19th and early 20th centuries. Its final purpose, to become a weapon of war through the application of human knowledge and skill, was something no one could have predicted when it first pushed up through the forest floor as a tiny seedling. But in that moment of impact, in those 30 seconds of falling and striking and destroying, the tree fulfilled a purpose that changed the tactical situation for kilometers around, that delayed an armored column, that contributed to the larger effort to halt the German offensive. The Somme River continued flowing past the ruined bridge site long after the conflict ended, its cold waters gradually eroding away the broken support beams and scattered debris. Local residents would point out the location to visitors for years afterward, though the physical evidence gradually disappeared as nature reclaimed the scarred earth. The timber supports rotted away in the river water, The twisted metal was salvaged for reconstruction projects. The disturbed earth was covered by new growth. Eventually, only the story remained, passed down through families and communities, evolving with each retelling until it became as much legend as history. But it was a story worth preserving, a reminder that war is not only about firepower and industrial capacity. Though those certainly matter immensely in determining outcomes, it is also about knowledge, about seeing possibilities that others miss, about having the skills to transform opportunity into action. Sergeant James Robert Clayton possessed all of these qualities, honed through years of patient practice in the forests of Oregon, developed through the accumulated wisdom of a family tradition that valued precision and competence above all else. When the moment arrived that demanded their application, when circumstances aligned to create an opportunity for unconventional action, Clayton was ready. He had the knowledge to see what others missed, the skills to execute a plan that seemed impossible, and the courage to act despite the enormous risks involved. These qualities, knowledge, skill, courage, are what ultimately define excellence in any field, whether that field is timber falling in peacetime or combat engineering during the largest conflict in human history. The German soldiers who had initially dismissed, or according to some versions of the story laughed at, the idea of a black lumberjack threatening their carefully engineered bridge learned a lesson that military forces throughout history have had to relearn repeatedly. Never underestimate an opponent based on appearance, background, or conventional expectations. The most dangerous threats often come from directions that seem impossible until they manifest, delivered by individuals whose expertise in seemingly unrelated fields translates unexpectedly into military effectiveness. Lieutenant Peterson's official report on the operation, submitted after the group successfully returned to American lines on December 28th, noted that Sergeant Clayton had demonstrated exceptional initiative, technical expertise, and professional skill in the execution of demolition operations using unconventional methodology and available natural resources. The dry bureaucratic language could not fully capture the audacity and brilliance of what had been accomplished, but it served its purpose, ensuring that Clayton received recognition for his actions and that the techniques he employed were studied and incorporated into engineer training programs. The bridge over the Somme River was eventually rebuilt after the conflict ended, this time as a permanent structure constructed with steel and reinforced concrete rather than timber. Modern engineers who examine the site and hear the story of its wartime destruction sometimes express skepticism that a single falling tree could have caused such catastrophic failure of a properly engineered structure. The scale seems wrong to those accustomed to thinking of trees as landscape features, rather than as potential weapons. But careful calculations based on the known dimensions of Hoffman's original bridge and the estimated size of the spruce tree confirm that Clayton's approach was not only feasible, but mathematically sound. A mature Norway spruce 90 feet tall and approximately 60 centimeters in diameter at the base would have massed between 8 and 10 tons. Falling from that height under gravitational acceleration, it would have impacted the bridge supports with kinetic energy measured in hundreds of thousands of joules, roughly equivalent to the explosive force of several artillery shells, but delivered as concentrated horizontal force rather than dispersed blast effect. The vertical support beams, designed to resist downward loads from vehicle traffic, had no significant capacity to resist horizontal impact of that magnitude. The failure was not a matter of poor engineering by Hoffman. His bridge design was entirely sound for its intended purpose. The failure resulted from the application of force in a direction and manner that no reasonable engineering standard would have anticipated or designed against. In the decades after the conflict, as the timber industry evolved and mechanized, the kind of hand tool expertise that Clayton possessed became increasingly rare. Chainsaws replaced axes and crosscut saws, making the work faster and less physically demanding. Heavy machinery, feller bunchers, skidders, processors, replaced human strength and precision, allowing single operators to accomplish in hours what had once required teams of skilled workers laboring for days. The younger generation of loggers could accomplish quantitatively more than Clayton's generation ever could, but they sometimes lacked the intimate understanding of wood and physics that came from direct, manual engagement with the work. The feel of an axe blade biting into wood, the sound of a saw cutting through different wood densities, the subtle shifts in resistance that indicated when a cut was reaching the critical depth. These forms of knowledge were becoming lost arts, preserved only by a shrinking number of traditionalists and historical enthusiasts. Clayton himself adapted to these changes, supervising mechanized operations with the same attention to detail he had once applied to hand tools. But those who worked with him noted that he could still read a tree better than any instrument, could still calculate full trajectories by eye with greater accuracy than computer modeling, could still identify structural problems that electronic sensors missed. Some knowledge, it seemed, could only be gained through years of direct experience, through the accumulated wisdom of 10,000 cuts and 3,000 felled trees, through the kind of deep expertise that comes from treating one's work as a craft, rather than merely a job. The military continued to study the Salm River Bridge destruction as a case study in unconventional warfare and the military applications of civilian expertise. Special operations units incorporated similar thinking into their training programs, teaching soldiers to identify and exploit environmental features that could be turned into weapons or obstacles. The principle Clayton had demonstrated, that expertise in civilian skills could translate directly into military effectiveness, became a foundational concept in the development of later Special Forces units and in the evolution of unconventional warfare doctrine. Perhaps most significantly, the story served as a powerful counterpoint to the racial prejudice that plagued American society both during and after the conflict. Here was undeniable proof that talent, knowledge, and courage had nothing to do with skin color, that a black soldier from Oregon could outthink and outperform opponents who believed themselves racially and culturally superior. The story could not by itself change hearts or minds. Prejudice runs too deep for single examples to eradicate, but it became part of a larger body of evidence that made racial discrimination increasingly untenable in military and eventually civilian contexts. Clayton lived until 1998, passing away quietly at the age of 82 in the same Oregon timber country, where he had learned his craft and developed the expertise that would serve him so well in that frozen Belgian forest. His funeral was attended by family, friends, and a surprising number of military personnel who traveled from across the country to pay their respects to a man whose actions had contributed to Allied victory in ways that most people would never know about. Among the attendees was a retired German-American engineer who had read Hoffman's report years earlier and had tracked down Clayton specifically to express his professional admiration for the bridge operation. The two men had maintained a correspondence over the years, discussing timber engineering and bridge construction, their shared professional interests transcending their wartime opposition. This engineer delivered a brief tribute at the funeral, speaking about the respect that true craftsmen have for each other, regardless of nationality or circumstances. The eulogy, delivered by Clayton's eldest son, touched only briefly on the military service, focusing instead on a life dedicated to craftsmanship, family, and the quiet satisfaction of work done well. "My father never claimed to be a hero," the son said, his voice carrying the same soft Oregon accent that his father had possessed. "He never talked much about the conflict or what he did during it. He claimed only to be a man who understood trees, who had learned through patient practice to predict how they would fall and where they would land. That he applied this knowledge to help end a terrible conflict was, in his mind, simply doing what needed to be done with the skills he possessed. He taught us that expertise is its own reward, that doing work well matters more than recognition, and that knowledge gained through dedication and practice is the most valuable thing a person can possess." And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.